I'm a developer advocate at Google. I work on our geo developer products, so Google Maps API, Google Earth API. You can follow me on Twitter. It's Ossama Alami. And you should follow the Google Maps API Twitter account. We frequently tweet about announcements, new features, and exciting use cases of our APIs. And that link up there is for the GDD agenda and to rate this session, which I hope you do. So today I'm going to talk about the Google Maps API version 3. We're going to learn how to build a map, learn about some new features, and sort of explore version 3 of the Maps API. But before we dive into that, I want to give you a little bit of history over why we decided to build version 3 of the Maps API. How many of you have used the Google Maps API version 2? Great. How about version 3? Oh, good. So there are some users out there. So version 2 of the Maps API has been enormously successful. It has over 350,000 active sites. It was built and released in 2005. It sort of started the whole web mapping and mashup trend on the internet. And not only does it remain as the web's largest used mapping API, but it's also one of the largest APIs used on the web, period. So in late 2008, the Maps API engineering team realized that if you were to load version 2 of the Maps API on that first generation iPhone, on that that great web browser that Apple released for a mobile device, it would take something like 20 seconds to parse the JavaScript and become usable. And I say usable sort of. You could use it, but it wasn't exactly a great experience. And when one of Google's tenets is that every millisecond counts, 20 seconds seems a little unreasonable. So the team decided that this was just not a situation that we wanted to be in. We couldn't have a mapping API that took 20 seconds or more to load on a mobile device, and we saw that the mobile web was certainly growing in usage, and we wanted to have an offering that was usable on the mobile web. So looking at V2, the team tried to optimize it as much as possible, but given the way it was designed and the fact that it was built to sort of meet all these different use cases, it has directions, it has polylines, it has editing of polygons and polylines, and it was built off a code base that was created in 2005 off of maps.google.com. They couldn't optimize it enough. They couldn't strip out enough things. They couldn't make it asynchronously loaded, that they decided that the way forward was to build a new mapping API designed from the ground up with mobile devices in mind, so optimized for mobile devices, but a full desktop mapping API. And so V3 was born. We released it at Google I/O in 2009. And in Google I/O in May of this year, we launched it from labs. We graduated the API. We said that this is now our new premier JavaScript Maps API, and we deprecated version 2 of the Maps API. Now, for all of you guys that raised your hands when I asked how many of you had built a V2 app, don't worry. V2, while deprecated, we are committed to supporting it for at least 3 years. So it gives you plenty of time to upgrade those maps to version 3. And we keep on adding new features to V3, which I'll talk about some in this session and some in the next session. So V3, wide support for various browsers, including specific support for the Android browser, iPad and iPhone browser. targeted towards mobile. And then for those of you that build V2 apps, you'll be happy to hear that we got rid of API keys, so you no longer need any API key to use the API. Before we get started on building the V3 map, how many of you, or I certainly have been consuming a lot of coffee in preparing this talk and in combating jet lag. And I'm from San Francisco, and some of my team is in Sydney, and both those cities have a very large coffee culture. And some of my team are kind of fanatic about finding great coffee and finding new places that have coffee. I don't know if Brazil has a big coffee culture. So this will be a well-targeted talk. We decided to combine our love of maps and our love of coffee and build something awesome. So what we're going to do today is, from start to finish, we're going to build a V3 application targeted towards mobile devices to let users, basically an application that crowdsources coffee reviews and coffee establishments, all on a map. So let's get started. The first thing we need is to build a map. This is the standard look and feel for Google Maps. It has the various map types. The street view is now enabled by default. Pan and zoom. So how do we go about adding this to a web page? Well, let's first start with a web page. It's pretty simple. All I need is a div, and I'll call it map, and I want my map to live in there. Let's do the style sheet. I want the map to basically take up the entire page, so I'll just set its height to 100%. And then the core of it, the JavaScript. I want you to notice here how little JavaScript it takes to get a map up and running. So this is like 6 lines of JavaScript. All I'm doing is loading the API here, and then creating a map, setting its zoom level, setting its latitude and longitude, so where I want it to be on the Earth, and then saying that I want to default to a road map. And then I'm adding an event listener here at the bottom. When the window loads, call this init function to load the map. And then one more thing I want you to notice is, while we don't have any API keys anymore, we do have this sensor equals false. This is a required parameter. It's either true or false. It refers to whether you are building this map based on some real-time sensor data. What that really means is if you are using GPS or geolocation to plot some data on the map or show the user's location. The API loaded doesn't change at all depending on what you pass in this function. This is purely for us to track how the maps are used and for us to satisfy certain data provider agreements that we have. So this 6 lines of code will get us the map that I showed you earlier. And that's all it takes. And V3 now has, by default, it'll load a default UI, so that includes the map type control up here, the zoom and pan control here, and then street view will be loaded by default. In V2, if you use that, you'd have to either set UI to default to get it to a default view, or manually add those controls to the map. You still have control over what the map shows. You can disable that and say, I don't want a zoom control, I don't want a map type control, I don't want street view. That's still an option for you, but by default, this is what happens. Also, that bit of code will run on an iPhone and Android browser without any other changes. And it will run in an experience that's appropriate to those devices. So if you load it on an iPhone, it will show up without the the zoom controls. It'll just, you can pinch to zoom on the mobile web, and that'll work fine. You notice it makes the zoom control smaller. It collapses the map type control. It knows sort of the context of how big it is and what devices it's running on. You don't need to customize it anymore to make it usable on an iPhone or on an Android. Since I am in Brazil, I'll talk about localization. This is actually something you don't typically have to take care of for the Maps API. By default, we will show the map in the language that the user's browser is set to. So if it's set to Brazilian Portuguese, it'll load Brazilian Portuguese. In most cases, you want that behavior. You don't want to force a particular language onto the user if they've already specified what they know. But you can force that behavior by just appending this @language parameter when you load the map. So obviously my browser is set to English. I don't speak Portuguese. So when we saw it over here, it was in English, but I'm forcing it to load in Portuguese here, and it shows up in the correct language. Since we're building an application that's really, we're crowdsourcing local data, we expect users to use this map on their phone. It's not particularly useful for me to show a map of San Francisco when I'm in Brazil. I want a map of what's around me, so I can see the coffee shops around me and I can rate the coffee shops around me. So we're going to make sure we use geolocation to put the right location on the map. This is not actually a feature of the Maps API. This is a HTML5 feature, widely supported across all the smartphone mobile browsers, as well as Safari and Firefox and Chrome on the laptop. I'm running Chrome right here. Let's see what the code looks like. Again, not a lot of code. Just need to check if navigator.geolocation exists. That means the browser supports geolocation. I will get current position and then just pan the map to that position. So that gets us this map. I have not told this map to go to this conference site where we're at right now. It's doing this via HTML5 geolocation. The next thing we want to do is add a marker to the map where the user is, because it's useful to know, relative to the rest of the area, where I am exactly. Markers are what we call overlays, and the Maps API supports a number of different overlays. Markers, polylines, polygons, info windows are considered overlays. So anything that you add to the map that has a sense of location could be considered an overlay. But we just want to add a standard Google Map teardrop marker at the user's location. Again, not a lot of code. I just create a new instance of marker, google.maps.marker, and I set the position to the position I got back from the geolocation. So I set its latitude and longitude to be where I am, and then I set the map on the marker. So for those of you that have used V2, you notice a difference here. On V2, I would say map.addOverlay and give it a marker. In V3, I say marker live on this map. So it's a different sort of design structure. If you want to remove the marker from the map at this point, you just set its map to null. So in this call, I would have null. So that's interesting. I love the red map marker. I put it all over my presentations. I'm a big fan. I have it on my laptop. But it's kind of overused on API sites. What's really more useful for a user is to give this indication that they are actually geolocating yourself. And various devices have used this sort of little blue dot with a radius that shows how accurate it is. So instead of the red map marker, let's do something custom and more usable. The code here, again, what I want you to take away from this talk is how little code I'm using to build this map. The Maps API v3 really easy to get started, really easy to build some pretty advanced applications with not a lot of code. All I'm doing is creating a new marker image and giving that marker image to the marker. So instead of just creating a new Google.maps.marker, I'm passing in this marker options object and saying the icon is this image up here. V3 also supports CSS spriting. So if you want to, one great way to improve performance is to have your images sprited. So that's, while I didn't do that for this particular icon, you can see how it's supported here. I am specifying the size of the icon and the point at where that icon begins. So if I had a big image containing a lot of different icons, I could specify a specific location in that image to represent my icon. And then the last point there is the anchor. A Google Maps marker, the red teardrop, the anchor would be at the bottom in the middle. Since I'm showing a blue circle, I want the anchor to be in the middle of that circle. Right? That's where the user actually is. So I just specify half the size in both the X and Y. And that gets us this location marker where we're at. But I mentioned that it's sort of been established when you display a user's location, you typically also show the accuracy. HTML5 geolocation can rely on Wi-Fi or, depending on the device, on GPS. So location, or on mobile devices, on cellular networks. So the accuracy of a location can vary quite wildly. So let's put a circle around where the user's location is so that I can give them an indication of accuracy of the geolocation. Whoops. This is a new feature in V3, this circle object. In V2, we didn't have a circle. So you would have to create some sort of image. We also have a new rectangle object that you can add to the map. Pretty simple. I just create the circle, give it some parameters for how I want the circle to look. And down here in Get User's Location, I am setting the radius of the circle to the accuracy of the geolocation. That's something that comes back in HTML5 geolocation spec. And then I'm just, again, like I would with a marker, setting the circle's map to be the map that I created earlier. One thing I want you to notice here is this bind to. V3 has this concept of MVC objects, which I'm not going to go into much depth in this talk, but we do have a great article on our documentation site called Fun with MVC Objects. You can learn all about sort of the architecture of V3 and some really cool new features. What I want this circle to do is I really want it to move with my marker, right? If I move my marker because the user has changed locations, I want the circle to move with it. So I need to add code that says when the marker moves, move the circle. In V3, it's really, really easy to do this. It's this one line of code. What I'm saying here is bind the accuracy circle's center to the user location marker position. So what happens there is when position changes, what's being called is accuracy circle dot set center user location marker dot get position. But you don't have to handle those events. With this one line of code, it'll automatically bind those two properties together. So, what do we have so far? We have our location marker and our circle of accuracy. Let's add a custom control so that, if I pan the map, I lost where I am, click my location, and I can quickly pan back to my location. A custom control is just an arbitrary div. So the first thing we want to do is style that div that we're going to create. I'm going to give it a class of button I'm just going to give it this style, which makes it look a lot like the controls that we have over here. I want it to look very similar. So I'm just going to give it the style. That's just standard CSS. And then the JavaScript, I am going to here add the div to the map as a control. I'm creating the div. I'm giving it the class of button. I'm setting its text to my location. And then I'm adding it to map.controls array at top right position. So the V3 API has a concept of controls anchored to specific positions. So top right, top left, top center, bottom center, all around the map. And it'll take care of laying out controls added to the map at a specific position. So I'm anchoring it to top right, but you know that I already have the map type control up in top right, so V3 knows to add it to the left of the map type control, but if the map gets bigger, it's still anchored to that right position. And that's all it is. I just create a div and add it to this array. I also want to do something when the user clicks the button, obviously. So I just listen to the button's click event and pan the map back to that user location I saved earlier. So what have we done so far? We've added the location. We've added a button to go back to the location. What else do we want to do? Well, we want to have the ability to add a shop, right? Because we want this application to both show me what coffee shops are around, but also allow me while I'm on the run, hey, I just had a great cup of coffee. I need to remember this place, add this location, rate it, let's say 1 to 5. So I clicked Add Shop. I'm going to just open an info window, which is, again, just another type of overlay, on top of this marker, and let a user enter a name, address, and a rating. And then, I'm just opening it where I think the user's location is, but obviously that might not be accurate, so I want to listen to a click event so that the user can then move this shop to specifically where it is, and then save accurate data. Again, this is very similar to the My Location button I added. It's just a custom div. The only point I want to make on this slide is that the Maps API is fully compatible with any JavaScript framework that you want to use. So if you're happy coding in jQuery, you can definitely use jQuery. With the Maps API, there's nothing that conflicts there. Anybody here use Google's Closure tools? One guy? So we also have an externs file for Closure, so you can use the Maps API. And in fact, the Maps API was built using Closure. So I want to pop open a new, or drop a new marker when I'm adding a shop, and I want to open an info window on that marker. Another difference between V2 and V3, V2 had one instance of info window throughout the lifetime of the application. So you can only open one info window on the map. V3 doesn't have that restriction. You can add 10, 20 info windows to the map. Arguably, that's not particularly useful, but you can now have the flexibility to have multiple open info windows where V2 didn't give you that. We have to be careful in migrating your applications, though, is if you want the behavior of only having one info window, you have to take care to keep track of that info window and make sure it moves around as you're opening and closes the old one. So all I'm doing here is I'm creating the info window. I'm giving it some arbitrary HTML, which I displayed by passing in content in this info window object. I'm creating the marker, and then when the map is clicked, I want to move the position of the marker. And then when I click Add New Shop, I want to again, move the position of the marker to the center of the map, set the marker to be on the map so it shows up, and then open an info window. You can see here I'm opening the info window on map, so that's basically saying set map on info on the info window, and I'm giving it a marker. An info window, you can set an info window's location. It doesn't need to be associated with a marker, but this is a shorthand way to bind an info window to a specific marker. So it'll get the behavior that we saw earlier, where if I click Add Shop, it'll drop the marker and open an info window. What would be really cool, though, is limiting the amount of text that a user has to enter, right? Especially on a mobile device. You don't want typing in the address. You have to ask the barista, it's like, what's the address here? That's not really a fun way to enjoy coffee. So let's see what we can do there. You can see as I click around, the address changes for where the user is. For those of you that don't know, this is called reverse geocoding. The Maps API has what we call geocoding, which is a process of taking an address and getting back a latitude and longitude. It also has reverse geocoding, which is the process of taking a latitude and longitude, sending it to our servers, and us trying to give you basically our best guess for what specific address you're at. So given that this is obviously a request to our servers, whereas everything we've done earlier was sort of synchronous programming where I'm adding a marker and it shows up on the map. Here, it's a request to our servers, so we need to add a function callback so that when that request returns, I can do something. But it's not much more complicated than that. I'm creating a new instance of geocoder. This geocoder class supports both forward and reverse geocoding. I am creating the request. In this case, you see I'm passing in a lat long. If I wanted to forward geocode, I would instead say address, and then the string that the address is. In this case, I'm just passing in the lat long of wherever that marker is. And I'm calling geocoder.geocode. When it returns a success, I'm pulling out that formatted address and adding it to that info window in that box. There's a lot of data that comes back, including a very easy way for you to parse specific address components, as well as a formatted address, which we're using, but also things like optimal viewing bounds for this element, be it a city or an intersection or an address. What's the optimal way to view this on your size map? But we're just going to use the formatted address. And then when the map is clicked, in addition to what we do up here is what we did earlier. We move the marker. We're also going to reverse geocode that new marker. So that gets us this code here, where I can move around, I can rate a store, and now I just want to enable saving a shop. So let's do that. Not much new code here. So all I'm doing is creating a new marker image. I want to have a custom icon for indicating a shop that's already been saved. So I'm just going to use this coffee.png that I have. I'm creating a new marker. I am, when I save, removing my red Google Maps marker, adding the custom marker that I created. So I'm removing the old marker by setting its map to null. I'm closing the info window, and I'm just creating a new maps marker with that icon at that position. So next we want to load shops, right? We want to load the shops that we have saved. Obviously this is a server, there's a server component to this. I'll make all this code available. I'm not going to go through the server component because it's not really part of the Maps API, but it's a very simple App Engine app built in Python that basically just has a very simple API to save and load locations. But when do I want to load a location? You can see there are 2 coffee shops here, which I actually didn't go to. I just randomly added some data. But if I zoom out, you can see I've sort of been using this application in North America and teams in Sydney, and we did a trip to Southeast Asia. So what you saw there is, as I panned out and then stopped interacting with the map, the application then loaded the coffee shops that were in the range of the map. When the application starts up, let's say this becomes really popular. I have thousands or tens of thousands or hundreds of thousands of coffee shops. It's not really useful for me to load a coffee shop in Sydney when I'm in Brazil. So what we want to do is add a new event listener. We're going to listen to the map's idle event. This is fired whenever the user stops interacting with the map. So if the user pans the map and then stops, idle will be fired. If he zooms in or if she zooms out, idle will be fired. And then I can perform some action based on that. What I'm going to do is I'm going to take the bounds of the map, and this toURL value just gives me a string format for the bounds of the map. That is the extent of the Earth that I am looking at in my current map view. I'm going to send it to my API, and it's going to come back with a bunch of stores. I'm going to iterate over those stores and add it to the map. Here, the only thing interesting here is I'm making sure to keep track of all the markers that I've added to the map in my own array that I've defined somewhere else. This is important because for the most part, the Maps API won't keep track of markers for you. You need to do this for yourself. And I don't want to keep on adding new markers to stores I'm already displaying on the map. And here you can see this is the actual function to add that marker. The only new thing I'm doing here is I'm setting a title. Title is basically an easy way for you to access the sort of on hover display of text. So when you hover over a marker that has a title set, it'll then display whatever the title is. So I'll show you that right now. If I hover over here, you'll see it shows a coffee shop. So let's click on this. I gave this coffee shop 3 stars. It's at that address. And it'd be great to get some sort of directions for how to get there. Let's click directions, and it'll map out directions. So the Google Maps API version 3 supports 3 types of directions. There's obviously driving directions. There's also walking directions. Since this application is, very kind of hyper-local, I am really only interested in places I'm going to walk to. I'm going to use walking directions. The other direction type that we support in some countries, not Brazil yet, is bicycling directions. But in this case, I'm going to show you how to use walking directions. You'll see the code here is actually very similar to the reverse geocoding we did earlier, right? Directions is just another service that Google provides. You send a request, you wait for a response, you handle that response when it comes back. So all I'm doing is creating that request here. I'm saying I want to go from where the user location is to the address of the shop. And you'll notice I can give the direction service an address, or I can give it a lat long. It doesn't matter. I can give it 2 lat longs. It'll route between those 2. I'll give it 2 addresses. I can give it 5 addresses, and it'll give a optimized route between all those 5. And then I'm just saying I want to do this walking. And then when the result returns, just render that result on the map using this directions renderer. I'm just going to show the route on the map, but the directions service does return textual directions, does let you render that standard look and feel for Google directions, and also lets you access specific direction steps so you can render it however you want. Excuse me. And here's our application. You can go to it right now. It's live. It's whereiscoffee.appspot.com. We built it basically for optimized mobile devices. This is what it looks like on a Nexus 1 or on an Android device. I can click Add Shop. I can click around to change that shop, change the rating. You'll notice here I'm actually pulling in some locations. We're using the local search API. You can take a look at the code yourself, but that's another way to sort of help the user guess at where they're at. I don't know what this is, but let's just add something to the map, and it should show up right there. And then this is what it looks like on a desktop. It's just a larger view of the same thing. You can very easily create a site that looks different for mobile and desktop, and in fact I encourage you to do that. But in this case, we're just showing the mobile view in a desktop web browser. So what have we learned today? We've learned about how to use the map, markers, overlays, controls, getting users location, using some of our services. What else is there? Well, there's quite a bit. There's polylines and polygons, which we didn't touch upon. There's traffic and bicycling layers. I tried the traffic layer in Brazil. I couldn't ever get it to show anything but red. Is that accurate? Styled maps, which I will talk about in my afternoon session, so I encourage you to attend that one. Street View, which I'll show you right now. So we launched Street View in Brazil, what, a month ago? Something like that? And my cab driver told me there's 130,000 streets in Sao Paulo, which sounds like a terrible thing for our Street View drivers. But it's a standard Google Street View experience. What's really exciting about V3 versus V2 is that Street View was built entirely in HTML. So since we targeted this API for mobile devices, we wanted to make sure that it's entirely usable on all mobile devices, and not all mobile devices support Flash, which our old Street View interaction was built upon. So this is all rendered in HTML. What this lets us do is allow you to have some really sort of new interactions with Street View that we didn't have in version 2. You notice I have a custom marker where Google Developer Day is here. Excuse me. We're right here. Let's toggle the Street View. I don't know if you can see it. It's actually right there. So markers can be shared between the map and Street View, and you can add markers directly to Street View. And what's cool is as I get closer to that marker gets larger or smaller. And I can also open arbitrary info windows in Street View. So that's cool, yeah? I'll show you something I find really cool, and that's the ability to do custom Street View. So again, we're at this location here at the Sheraton. Let's click Street View, drag it, well, let's say over here. So this is the standard Street View experience. As I drive down the road, oh, what's this? You can see I added a little GDD 2010 leading to the Marriott, or sorry, the Sheraton, the Sheraton over there, where we're having this GDD. This is obviously not something you'll see when you go to maps.google.com. It does not have real-time events. But what happens when I click here? So yesterday, when I got in town, I took just a standard Canon point and shoot on a little tripod that I sort of perilously tried to hold on a chair, and rotated around and took a bunch of pictures. And you can see how a conference is set up the day before. And then stitched it together with software called Huggin, which is just something I found and downloaded off the internet. And then added a custom street view, which is really easy to do in V3. So you can jump into the speakers room. You can see some other Googlers here, a lot of jet-lagged faces. You can see I was a little slow taking these panoramas, so she's over here, and she's over here. I can turn around and jump into the speakers, or sorry, I was just there. Jump into the keynote room. And then you see also Chris is apparently pointing at himself, and also on the stage. So very cool functionality, not a lot of code. Basically the way this is done is you have a way to provide a custom tile URL to the Street View panorama. The map works by tiling, so we have a set of tiles. Street View works very similarly. So you can take a panoramic photo, cut it into tiles, and then specify to the Maps API how to load those tiles. This is the right way to do it. You want to tile it because it's a lot easier to load tiles, and then you can have different resolutions at different zoom levels. But if you want to do the quick and dirty thing, which is what I did yesterday, I just took one big image and plastered it into Street View without tiling it, and it works fine. These are large images. They're about a meg each, which is why you'd want to tile them so that you don't have to serve a meg worth of data. And you can see there's a fair amount of code here, but it's not that complicated. In this case, I'm returning a specific panoramic image based on where or what Street View I want to load, and then how I link between different panoramics is just specifying a heading and an ID for that panoramic image. And then down here, I link specifically to our Google Street View imagery. So what I'm doing here is when I'm at a specific lat long, I recognize that I'm close to GDD. I then add a new link, and it'll show up automatically in Street View. So you can, if you're building a store locator, for instance, and you want to provide a way for the user to navigate into the store, you can do this with our Street View imagery, leading into your custom, imagery. So that's what I wanted to cover in this session. Please come to my session this afternoon where I'm going to talk about some other new features in V3 and across Geo as well. The presentation is right here at this URL. I encourage you to load it in Chrome. It might not work otherwise. The code or the documentation for the Maps API is here. The application Where is Coffee is here, and the code for Where is Coffee is right here. Thank you very much for your time.